Hello, pre-calculus students. This is Mr. McAllen, and today we are working on day one of Unit 8, and this is on sine and cosine functions. So this video is on just basic graphing of the sine and cosine function. And the first thing we need to do is remember our quadrantal value table. So I'm just going to fill that out real quick. Remember that the values at 0, 90, 180, 270 and 360 were as follows for the sine function. The sine function was at 0, then at 1, then at 0, -1, and 0. Now when we plot that, if we look down here below, I'm going to plot the sine function. Y is equal to the sine of theta. Theta is the x-axis. I'm going to just change the color of the ink I'm drawing with so you could see that this is pi over 2 radians, this is pi. And remember we talked about what the radian amounts were, because we really should be graphing now, instead of using degrees, radians. So we're going to mark up our x-axis with those values. And if we go to 0 degrees, or 0 radians, we were at 0. So I'll mark that with a red dot. And then when we were at pi over 2, we were at 1. So that's equal to 1, that hash mark. Then we came back to 0 at pi radians. Then we went down to -1 and back to 0. It's really important that when you draw this function, you draw it with the right type of concavity. The sine function is a smoothly transitioning function, and you should draw it as such. And this function is a periodic function, so it will repeat itself over and over and over again. But we're only going to concentrate on the first period right now from 0 to 2 pi. Now we come over and we're going to graph the cosine function. So we're going to fill out our table. Remember at 0, we were at 1 for cosine. Then we went to 0. We were at -1 for pi radians, or 180 degrees. Then we were back at 0, and then we returned back to 1. So again, I'm going to mark out, I've got pi over 2. I've got pi. I've got 3 pi over 2, and then I've got 2 pi radians. I start at 0. I was at 1. At pi over 2, I went back to 0. Then at pi, I was down to -1, and so on and so forth. So I'm drawing the function, and here you see we have, the function has frowns and smiles in it. So remember to draw the function concave down in the right region and concave up in the other. Please do not draw this function as a sawtooth. Now, a few things we got to talk about with this function. We have ways of writing it for when it gets shifted and translated, and we have certain words for these that apply to physics and other areas of science when they use a trig function. And we have this thing called the amplitude, period, phase shift, and a vertical shift. These are all things that can be related to these coefficients. So when you write out, like we graphed y equaled sine of theta, our amplitude value was 1. So the amplitude was equal to 1, and x is replaceable with theta. And our b value for our frequency, because there's nothing in front of that, so we just assume there's a 1 there, the b value was equal to 1. The phase angle isn't there because we don't see parentheses. So the phase angle was 0. And the vertical shift, because you don't see anything being added to the function, the vertical shift was equal to 0. So don't worry what these coefficients mean for tonight's video. Just all we're worried about is, can you look at an equation and can you recognize the coefficients? Because before we explain what the coefficients do, we really want you to recognize what they are and if they are in the equation. So we have some examples. So if you look at example 1, I'll do this one with you. If you look at example 1, it says that, for the function y equals 3 sine of 2x minus pi. And, as you look at the function, you should be looking for the let me change back to a pen, the A, B, C, and D value. And right here, the first thing is to see the coefficient in front of the sine is the amplitude. So the amplitude is 3. The frequency is the coefficient in front of the x, that's 2. The phase angle is equal to -pi. because normally that's a plus, but because the phase angle was negative, they just put a negative there instead of a positive. And the vertical shift is -1. So what does this all mean? We're going to work on that together in class tomorrow. I need you to be able to recognize what these coefficients are before we start graphing them tomorrow. Example 2. Now you see it looks a little bit different. I'm going to pause the video and I want you to try to figure out these values and fill them in. And then when I unpause it, we're going to compare answers and um, hopefully we're good. So anyway, I'm going to pause the video. You give it a try. Okay, so the amplitude was equal to 1. The B value was equal to 1. The C value was -pi again, and the D value was -1. So people might say that the A value was 0 and the B value was 0, but because they're coefficients in front of the function and the x, they can't be 0. So the next one, looking at this equation, let's find the amplitude, um, uh, frequency, phase angle, and vertical shift again. I'm going to pause the video. Let's try it one more time. Let's see if we have any better luck this time. And go. Okay, well, we're back. And so the amplitude is 1 again, because the coefficient in front of the function, if there's no number there, it's 1. The frequency is 2. That's easy to see. Now, here's an interesting thing. A lot of people want to say that the phase angle was -1, but there were no parentheses. So if you notice in this last example, when there are parentheses, that is closing off the inside of the function where the phase angle sits. That's the phase angle. And if they don't have parentheses, then you just assume that that answer being added at the end is the vertical shift. So hopefully this video has helped you understand how to pick out these values, and tomorrow in class we'll be spending some time graphing them and looking at how all these things affect the original function that we saw here at the beginning. Look forward to hearing your comments, and please make sure if you have any questions or comments, you either ask me in class or add them to this video at the end of the YouTube feed. Thank you.